In this question, we have a projectile that was shot from P and it arrived at Q. So the acceleration of free fall is G. Remember, the air resistance is negligible. So let's note that. Which equation for R is correct? So in analyzing a question like this, let's keep note that in the horizontal direction of a projectile, the velocity is constant. So the horizontal velocity is constant, so which means that the acceleration in the horizontal direction is zero because the speed is constant. So let's note that. So normally on the horizontal direction, the only formula that we use is velocity equal to displacement over time. So let me just say, so your velocity or your speed is equal to your distance over your time. So when you are talking about projectile motion in the horizontal direction, this is the only formula that you use. Okay, but when you are dealing with vertical motions, then you use your SUVAT. So very important. So note that the horizontal motion and the vertical motion are independent of each other. So the only quantity which is the same for the vertical and the horizontal motion is time. That is the only quantity. So to analyze this question, since we can see that the only parameter which is the same in both cases is time, so the strategy is we find the time in the horizontal direction for the ball or for the projectile that was fired to move from P to Q in the horizontal direction. So we find the relation for the time, and then we do the same thing in the vertical direction for time also. Then we equate them to find our arrow. So let's get to it. So before you do that, this velocity that is here, you must resolve it in the horizontal, which we call it Vx, and then the vertical, which we will call it Vy. So you must resolve them. So for our Vx, that will give us V cos theta. And for the velocity in our vertical direction, we call it Vy. That will be V sine theta. Good. So it means when we are dealing with the horizontal motion, when we are dealing with our horizontal motion, which means that our speed here will be the velocity in the horizontal direction. So that is V cos theta. And then the distance in the horizontal from P to Q, that will be our R. So we can therefore say that our time, which will be equal to our displacement or our distance, which is R, over the speed in the horizontal direction. So which means our time in this case will be equal to our distance in the horizontal direction, which will be R, over our speed in the horizontal direction, which is Vx. So this time, which will when we want to write in terms of V, that will be V cos theta. So this is for the horizontal. So we are going to do the same thing for the vertical. So if we are looking at the vertical, you must use our SUVAT. So the formula that we can use for that will be S is equal to UT plus half GT square. Obviously, we are shooting the projectile upward. So our G here becomes negative. So we have S equal to UT minus half GT square. Good. But remember, if we are looking at it vertically, you see we shot the thing from P and then it arrived at Q. So which means we are looking at the displacement vertically from P to Q. Vertically, you can see the P and Q, they are at the same level, which means that the vertical distance from P to Q is actually 0. So look at it. You can see that the P and Q, they are the same level. So which means vertically, the displacement is 0. So which means our S here is 0. Equal to, so our initial vertical velocity, which is Vy. So we are finding our Vy expression here, which is V sine theta. So here becomes V sine theta times our time, okay, times our time, which is here, minus half GT square. So if I bring my half GT square here, half GT square will be equal to T V sine theta. Okay, so I can cancel one of my t's and then I can multiply through by 2. So that will give me GT, because one of my t's have cancelled out. So my GT will be equal to 2V sine theta. Okay. All right. So like I said, we are also going to make t the subject. So if I make t the subject, I'm going to get 2V sine theta over G. So which means the time, if you are considering the horizontal, and the time if you are considering it vertically. So the time for the horizontal motion and the time for the vertical motion are equal. So since they are equal, it means that I can equate this equation 1 and this equation 2. I can equate them. So with that, I will get R over V cos theta to be equal to 2V sine theta over G. So if I make R the subject, I will get R to be equal to 2. So there's V here, there's V here. So that will give me 2V squared sine theta cos theta all over G. So if I compare, it means my answer is B. So correct answer is B.